Hello, I Anand Jain from Hanumangarh, Rajasthan welcomes you to your favorite Shridevi Classes YouTube channel where we inculcate interest and confidence in science and engineering subjects. Today in our basic electrical engineering and class 12th physics in our chapter alternating current circuits will understand angular frequency and its time related angular measurement argument, and will understand how the instantaneous magnitude of sinusoidal alternating quantity varies with time, and that variation is represented by phase. So we will learn about phase representation for instantaneous magnitude in sinusoidal alternating quantity. Let's start. An alternating current or voltage continuously change its magnitude as well as direction with respect to time, as illustrated here in this wave diagram. A standard sinusoidal wave is shown here. It starts with zero instantaneous magnitude at time zero condition, and its magnitude increase in one direction continuously, and after a certain time interval it attain positive peak, and then it start decreasing its magnitude. Once again this decreasing pattern attain zero magnitude, and after that zero. If it is current, it change its direction, and if it is a voltage, it change its polarity, and the same repetition take place in other direction, with first increase of magnitude in other direction, then the decrease of same, and will find symmetrical positive half cycle and negative half cycle respectively in magenta circle and red circle, and this combination known as a cycle got unique non-repetitive value at different instant, and the same repetition takes place afterwards. For steady state analysis of this alternating current or voltage relationship in our electric circuit and power system, it is essential that we should understand mathematical formation of this sinusoidal wave and learn phasor representation of alternating current. So we will start with first trigonometric expression for this sinusoidal wave, and then we'll use exponential relation and phasor representation for the same. The time variation of standard sinusoidal quantity is shown here in this graphical wave, and it start with instantaneous value 0 at time 0 condition and increase in positive direction with a typical fashion. The magnitude of current or voltage at any time instant is known as instantaneous magnitude, and instantaneous magnitude of voltage or instantaneous magnitude of current shown by small v and small I are mathematically represented by this yellow highlighted trigonometric relation. Likewise, instantaneous current small I is represented as Im sin omega t or Im sin alpha by mathematical trigonometric manner. Here this Vm is the magnitude of maximum value attained by sinusoidal variation in either positive direction or negative direction. This is known as peak value, maximum magnitude or amplitude. Similarly, in this I is equal to Im sin omega t relation, Im is peak magnitude of current or maximum value of current or amplitude of current, and sinusoidal signal got a symmetry, and its positive peak and negative peak are identical in magnitude. Here in this mathematical expression, this alpha is an angular measurement known as argument, and it is a angle measurement which varies with time as product of omega and time. Alpha is equal to omega t, and sine of that angle alpha or omega t when multiplied with peak magnitude gives us instantaneous magnitude. So the variation of sinusoidal quantity at various instants or instantaneous value of sinusoidal current is given as Im multiplied by sine of a time function known as argument. Now this angle or argument is an angular measurement, and for one entire non-repetitive value set which repeat itself as shown here in green highlight known as a cycle, the total argument of one cycle is taken as in degree system 360 degree, and in radian angular measurement it is considered as 2 pi radian. Now this cycle is proportionally divided from 0 to 360 degree or 0 to 2 pi radian, and for any time condition as per argument value, the sine Sine of that argument when multiplied with maximum value gives us instantaneous magnitude of sinusoidal quantity, whether it is instantaneous voltage or instantaneous current, as shown by this graphical wave expression or mathematical trigonometric relation. In trigonometric expression of instantaneous voltage, this multiplier Vm in front of this trigonometric sinusoidal function is known as peak value or amplitude of voltage. Similarly, in this instantaneous current relation Im sin omega t, this Im is maximum magnitude or amplitude of current. Sinusoidal relation got a symmetry and their positive peak value and negative peak value are identical in magnitude, and also this variation of instantaneous magnitude in one positive direction as shown in this blue ellipse and variation of instantaneous magnitude in opposite direction shown in this red ellipse also got symmetry, and after every such half cycle sinusoidal alternating quantity alter its sign. If it is current, it alter its direction, and if it is voltage, it alter its polarity, and these alterations repeat themselves again and again. This entire set of positive half cycle and negative half cycle shown in this cyan frame or yellow highlight is a cyclic variation of standard sine wave which starts with 0 instantaneous magnitude at time instant 0, and first it increase in one direction, attain peak, then decrease to 0 value at instant B, and similar pattern increase in opposite direction and decrease in that direction repeats, and now this cyclic variation repeat themselves. Now in this cyclic variation all instantaneous magnitudes are unique in nature, they are nowhere repeated in a cycle, and such cycles are repeated again and again. So we can consider the duration of this cycle in terms of time as time period capital T, or in terms of angular measurement as 2 pi radian, and at different time instant or angular position instantaneous magnitude got unique different position. So the position of instantaneous magnitude or condition of instantaneous magnitude or phase of instantaneous magnitude can be represented in terms of time or angle, and such representation of instantaneous magnitude in terms of time or angle is known as phase representation of sinusoidal quantity. We can say that variation of instantaneous magnitude of sinusoidal wave, whether it is instantaneous current or instantaneous value, has a simple, unique, distinct, non-repetitive magnitude for all different values of time instant or angle argument position for this entire cycle of time period capital T or angular measurement between 0 to 360 degree or 0 to 2 pi radian during this one cycle variation. Unique non-repetitive condition or phase of instantaneous magnitude of voltage or current in a standard sinusoidal wave can be represented in terms of time or angle, and time period of entire cycle is taken as capital T, and angular measurement of entire cycle in degree system is 360 degree and in radian system it is 2 pi radian. And when instantaneous magnitude in this standard cyclic variation is at 3/4 of cycle position, then time for that instant is 3t by 4, and in angular measurement this is position of 270 degree or 3 pi by 2 radian. Similarly, this half cycle position when alternating signal is altering its sign, current is changing its direction and voltage is changing its polarity and crossing 0 position is position of t by 2 or 180 degree or pi radian position. In this standard wave, this position of positive peak 1/4 of time period or 90 degree or pi by 2 radian in angle. Similarly, this section of first quarter, if elaborated, then this sinusoidal quantity got half of its positive peak value at t by 12 time position or pi by 6 radian or 30 degree angular position. Similarly, at t by 8 position or pi by 4 radian or 45 degree position, it will have 70.7% magnitude of positive peak. At t by 6 position or 60 degree angle or pi by 3 radian position, it will have 86.6% value of positive peak and is in increasing order. So these unique non-repetitive value of a cycle can be represented in terms of time or angle, and both degree or radian measurement of angle can be used, and this table can make proportional calculation with time of entire cycle is capital T and angle for that cycle is either 360 degree or 2 pi radian, and proportional calculation can be made for any other time or angle positions. As shown in this cyclic variation of standard sinusoidal wave, the instantaneous magnitude starts with 0 instantaneous value at time t equal to 0, and in first quarter cycle from 0 to t by 4 it increases from 0 value and attain positive peak in a non-linear fashion. Near 0 instantaneous value, the rate of change of instantaneous magnitude is faster, and this rate goes on decreasing, and after positive peak it start decrease in its magnitude, first at a lower rate and then at higher rates, and after half cycle it complete its positive section and alter its sign, current change its direction, voltage change its polarity, and the similar things happen in negative half cycle. First the magnitude increases in opposite direction, attain negative peak, then it decreases and attain 0 value, and this similar cyclic variation when repeat itself, then the position of instantaneous magnitude can be represented by notation of time or angle of this standard cycle in terms of time t or angle in degree or radian. The complete set of unique positive values and negative values which are repeated onwards is known as cycle, and time duration of this cycle denoted by capital T is known as time period of sinusoidal alternating quantity. Here in this blue frame also a complete cyclic set of alternating quantity from positive peak to again positive peak is shown, which is repeating itself. So this duration from instant A to D is also time period of the same alternating quantity. Now number of such cycles which are repeated in 1 second duration is known as frequency. T is time period of one cycle, so time period of f cycles or frequency number of cycle is 1 second, and from this relation we can say time period and frequency are inverse of each other, and out of time period and frequency if one is known to us we can find out another one. Total angular measurement of one complete cycle having duration equal to time period capital T is assumed to be total angular measurement of a closed circle or 2 pi radian. So when this small t become capital T, this argument omega capital T will become equal to 2 pi radian, and from this expression we can find out relation of omega, which is 2 pi divided by time period, and 1 by time period is frequency. So this omega is 2 pi f. This omega got a relation with angular measurement argument and frequency. So here this omega is known as angular frequency, and it is measured in radian per second unit. Angular frequency, linear frequency in hertz, and time period in second, all three are interrelated, and out of three if any one is known to us, other two can be obtained. It is given that frequency of Indian domestic electric supply is 50 Hz. Our electric power system works near 50 Hz with plus minus 3% variation. If Indian domestic electric power supply frequency is 50 Hz, then we have to find out angular frequency in radian per second and time period of this supply. So we know angular frequency of alternator in terms of linear frequency is given as 2 pi f, and when f is considered as 50 cycle per second, radian per second angular frequency comes as 100 pi radian per second, and in place of phi if we take 22 by 7, angular frequency comes nearly 314 radian per second. So for 50 Hz Indian power supply frequency, the angular frequency is 314 radian per second, and vice versa. Now the time period of this supply is inverse of frequency, that is 1 by 50 second, and in millisecond it comes as 20 millisecond. Here in this standard sinusoidal alternating wave which starts with 0 magnitude at time 0 condition and increase in positive direction. After quarter cycle, it attain positive peak value, and this position of positive peak, position A, corresponds to 1/4 of time period of entire cycle, that is it's the instant of t by 4 time. And in terms of angular measurement, when complete cycle angular measurement is 2 pi radian, this is 1/4 of 2 pi, pi by 2 radian, or in degree it is 90 degree. So one can say this condition of instantaneous magnitude positive peak is condition of t by 4 time instant, or is a phase of pi by 2 radian or 90 degree angle. So we can represent condition or position of instantaneous magnitude in this sinusoidal alternating wave in terms of time or angle, and this representation of instantaneous magnitude for this standard sine wave is called as phase. This standard sine wave starts with 0 instantaneous magnitude and increase in positive direction, then decrease, complete positive half cycle, and then make a symmetrical negative half cycle and complete its cycle, and the entire cycle time duration is taken as time period capital T, and angular argument of entire cycle is taken as either 2 pi radian or 360 degree. The position or condition of instantaneous magnitude on this waveform is represented in terms of time and angle, and that is called phase of instantaneous magnitude, and phase is represented as fractional part of entire time period or fractional part of angular argument of entire cycle, 2 pi radian or 360 degree. Now out of these three, time in second or angle in radian, the more popular approach is to represent phase in terms of degree angle, and entire cycle is considered as of angular span 360 degree, and half cycle become 180 degree, quarter cycle become 90 degree, and we could have proportional fractional part of angular measurement to represent condition or position of instantaneous magnitude on this sinusoidal wave. The usual practice of considering phase angle for positive half cycle is from 0 degree to 180 degree, and for negative half cycle it is considered as 0 degree to minus 180 degree. So entire cycle is considered in between 0 to plus minus 180 degree, and for this we consider 360 degree angular measurement as equivalent to 0 degree. To find out equivalent value of 270 degree in plus minus 180 degree range, we subtract 0 degree from 270 degree, and 0 degree is equivalent to 360 degree, and when 360 degree is subtracted from 270 degree, it comes as minus 90 degree. So 270, this position I, is equivalent to, when we measure from another side with negative measurement, minus 90 degree. So we can say the condition of positive peak is condition of t by 4 pi by 2 radian or 90 degree, and condition of negative peak is when instantaneous magnitude I is minus Im, where Im is amplitude of current in negative direction, is minus 90 degree or 3t by 4 or 3 pi by 2 radian. In a cycle, sinusoidal quantity got twice 0 instantaneous value, as at this instant O and at instant F. At both these conditions, the instantaneous magnitude of sinusoidal quantity is 0. But these two 0 got two different phase conditions. One is 0 degree, second is 180 degree, or in terms of time, one is 0 time and another one is t by 2 time instant, or in radian angle it is 0 radian and this is pi radian. Now in this first O position, when instantaneous magnitude is 0, it is reversing from negative side to positive side, so it is negative to positive crossing 0, whereas at position F at t by 2 or 180 degree or pi radian position, in this phase condition, instantaneous magnitude is 0, but it is becoming positive to negative at this time instant, crossing 0 instantaneous value. So this position of O and position of F are different phase. One is of 0 degree, another one is 180 degree. They are opposite phase. Both positive half and negative half got a symmetry but of opposite sign. For positive peak at plus 90 degree phase position of instant C, we have positive peak instantaneous magnitude, whereas at phase condition of minus 90 degree, the instantaneous magnitude of sinusoidal quantity is the same as that of plus 90 degree position, but this positive peak and this negative peak got opposite sign. Similarly, at plus 30 degree phase instant and minus 30 degree phase instant, the instantaneous magnitude got same value, but for plus 30 it is positive in sign and for minus 30 degree phase it is negative in sign. So if we understood positive half cycle variation, then negative cycle variation can be obtained just by inverting the sign of positive cycle values for positive cycle phase conditions, because positive half and negative half got a symmetry but opposite signs. In this standard sine wave, positive half cycle also got a quarter wave symmetry at two sides of this positive peak at instant C in first quarter shown by blue frame and in second quarter shown by a red frame. The instantaneous values got symmetry at both sides. If we have a 30 degree angular displacement from positive peak to both sides, from positive peak of 90 degree, if 30 degree phase is reduced and we got 60 degree phase position, and similarly when 30 degrees added and we got 120 degree phase position, then the instantaneous magnitude of instant B and instant D would be the same. So it is sufficient to understand variation of instantaneous magnitude in this first quarter, and same first quarter symmetry can be applied to this second quarter, and we can find out condition of instantaneous magnitude or phase anywhere in this positive half section. As explained earlier, we can explain phase in terms of both time and angle, but angle measurement, that too in degree system, is most convenient to represent position or condition of instantaneous magnitude in terms of phase. So for phase representation of instantaneous magnitude, we preferably use degree angle system. And in positive half cycle, the first quarter from 0 to 90 degrees symmetrical to second quarter, that is between 90 to 180, and positive half cycle is symmetrical to negative half cycle. So if one understand this 0 to 90 degree duration in detail, then he could use that approach to other part of this sinusoidal wave perfectly. It is most important to understood that a sinusoidal variation from 0 to A, B and C in this first quarter of positive half cycle is different from linear variation of magnitude. In sinusoidal variation, when instantaneous magnitude is crossing zero value, its rate of change is high and it attain 50% value in 1/3 angular measurement or at 30 degree position only, whereas in linear variation 50% value will be obtained in half of quarter variation, that is at 45 degree. But in sinusoidal variation at 45 degree we will have 70.7% value of peak magnitude. So this sinusoidal variation is fast and rapid near zero crossing, and variation got smaller rate of change near peak value. In first half 70.7% value will be obtained by sinusoidal increase, whereas in next half of this quarter only 29.3% increase will take place. So we can say this sinusoidal variation is not a linear variation. Its rate of change got a higher rate near zero cross, and rate of change become smaller near peak magnitudes. Near zero, when rate of change is higher, half of peak value will be achieved in just 1/3 duration, whereas in the same 1/3 duration near peak only 13.3% value change will take place. So it is quite clear that this sinusoidal variation is not a linear variation, it's a non-linear variation. Near zero cross the rate of change got higher pace, and near peak instant rate of change becomes smaller. We hope this beautiful learning video has enhanced your subject understanding about alternating quantities. Now you could understand what is a relation of angular frequency and argument, and how instantaneous magnitude can be understood in terms of phase, and phase can be represented both in time and angle, but degree angle system is most convenient and also most popular. Our other learning video of the same playlist are equally useful. You can use them in your studies or refer them to your friends. And if you need dedicated exam centric notes or online doubt clearing classes from this channel, do join our YouTube membership. Happy learning. Have a nice time. Thank you very much.